All right, so now that we know what the parent function looks like, now we're going to take a look at transformations on that parent function. All right, so let me get through here. We're going to look at that here in a minute. Oops. All right, so our parent function again was f of x equals 1 over x. What we're going to be looking at is some transformations to that parent function. So here are a couple of things. We've got an a, we got an h, and we got a k. Each one of these is going to perform a different transformation on our parent function. A will do something to the graph, h will do something different to the graph, and k will do something else to the graph. The question is, what does each of those do to our graphs? Well, let's take a look here. Let's start with the a. What exactly is our a going to be doing to our graph? Well, it can do one of three things. That's why we have three blanks down here at the bottom. It says vertical blank, blank, or blank. What are the three things that a is going to do to the graph? Well, the first thing it can do is it can stretch it. We can have a vertical stretch. And we'll talk about when we have a vertical stretch here in a second. What would be the opposite of stretch? Compressing. Okay, so we can also have a compression. So we can also compress the graph vertically. Or, there's one other thing. Can you think of the other thing besides stretching and compressing? Flip. What do we call a flip? Reflection. So these are the three things that A will do to our graph. It will stretch it, compress it, or reflect it, depending on what the number is. So let's start with stretching. When is it going to stretch it? What kind of A do I have to have in order to see a stretch, a vertical stretch? You're going to have an A value that is greater than a 1, like a 2 or a 3 or a 4. Obviously, the bigger that number is, the more you're going to be stretching it out, just like we did with our quadratics. Compressing. When do we compress the graph? Well, that's going to be when the number A is between what? Between a 0 and a what? Like a 1/2, a 1/3, a 0.6. Anything that falls between 0 and 1 would compress the graph. When do we get a reflection? What kind of A value do we have to get in order to have a reflection? A negative. Well, that means that A has to be a number less than 0. Anything less than 0. In other words, any negative number would cause a reflection in the graph. Reflection over the x-axis. So this is what our A is going to do to our parent function. You notice a lot of this stuff sounds familiar from our quadratics and our radical functions. Everything we did back then still applies. Now let's look at the H. What is the H going to do to the graph? Well, they're kind of giving you a hint with these arrows right here. What are they trying to tell us right there with those arrows? What is the H going to do? Nope. What little arrows mean? Moving it left and right. Moving it sideways. So what's going to happen here is we're going to have a horizontal translation or shift, sliding it. So the question is, when are we going to move to the right and when are we going to move to the left? Now before you answer that, you remember when we were working with our quadratics and our radicals, we've got this up here. When I want to move to the left, I did this. When I want to move to the right, I did this. So be careful here. Those transformations that we talked about before, it's the same idea here. So when I want to move right, what do I got to do when I want to move right? Subtract. Of course, that means if I want to move to the left, we're going to do that when we add. When we add, we move to the left. When we subtract, we move to the right, just like we do with our quadratics and our radicals. That only leaves one more, and that's the K. Again, the K does something to the graph, and they're trying to give you a little hint right here with the little arrows. What are they trying to tell us with those little arrows? And it's going to move it up and down. So again, we're going to have a vertical shift or translation. So the question is, when do we go up and when do we go down? Let's start with going up. When are we going to go up? When you add. When do we move down? When you subtract. So I'm not giving you a whole new set of rules. We're just applying those rules that we've talked about before to our rational parent function. Okay, so now that we've looked at the rules, let's take a look at a couple of graphs here. Here's 3 different graphs. It's our job to come up with the equation for each of these graphs. So we'll start with this first one over here. I'm going to start with the parent function, 1 over x. Now obviously the graph we see there is not the parent function. And that's because that graph has been moved. The question is, where has it been moved? Has it been moved to the left? Did we move it to the right? Did we move it up? Did we move it down? Where did we move it? To the right. How many times did we move it to the right? Can you tell how many times we moved it to the right? Help? Too much? 4, 3. 3. We're looking right here. And we can tell it's been moved over 3 if you look at the vertical asymptote. Because for our parent function, the vertical asymptote was going through the y-axis, okay, or through 0. Now it's going through the 3, which means we've been moving it over 3 units. So if I want to move 3 units to the right, what do I got to put in my equation? Minus 3. And that needs to be subtracting 3 from the x. Okay, so we got 1 over x minus 3. That's the equation for that graph right there. Let's try the next one over here. Again, what's the equation for that graph? I'm going to start with my parent function, 1 over x. But again, that's not the parent function. That graph has been moved. The question is, where did we move it? Did we move it left? Did we move it right? Did I move it up? Did I move it down? Where did we move it? What's that? We moved it up to, we moved it up, but not quite to 1. I'm looking right here. We noticed that we moved it up 1. But before I do that, did I move left or right? No, all we did was move up 1 unit. So if I want to move my graph up 1 unit, what do I got to do to the equation here? Plus 1. Now make sure that plus 1, you're adding to the function itself, or the 1 over x. So this is the equation for that graph. We got one more to look at over there. We need the equation of that graph. Again, I'm going to start with the parent function, 1 over x. Now this graph has been moved in 2 different directions. What's one place that it's been moved? Up? How many up? 2. What else? To the left, 1 unit. So let me start with moving to the left 1 unit. If I want to move to the left 1 unit, what do I got to do to my equation? Plus 1. And that plus 1 is going to be down there with the x. Adding 1 to the x. Now I want to move it up 2. So if I want to move it up 2, what do I need to add to my equation? Plus 2 on the outside. That's our k. Plus 2. Therefore, this is the equation for these graphs here. All right, before we go ahead and stop, just real quick, this equation here, or this graph, what would be the domain for that graph? What are the x values for this graph here? Everything except for what now? What's that? -1. Remember, it's where our vertical asymptote is. All you got to do is look for the vertical asymptote, and you'll find your domain. What about this one right here? We're looking for the domain. What are the x values? Everything except for what number? 0. Look right here. Once again, I'm looking for the domain. The domain is all the numbers except for one of them. What's the number we can't have for our domain? 3. Again, all we're doing is looking at the vertical asymptote. So if you can find your vertical asymptote, you shouldn't have a hard time finding your domain. All right, so that takes us through transformations of our rational parent function.